Of singly linked list, here we know that it is represented in this manner. This is null, and you are having one start pointer, and that will be pointing to the very first node. So this is your first node, this is your second node, and this is your third node. This is how the data is stored in the linear form, even if these nodes are present in different addresses, but how they are linked, since they are linked in the linear form, therefore whenever you access the linked list, you will get the data in the sequence order. Because suppose this is 100, this is 200, and this is 300. These are the addresses of these nodes. First part will have the data supposed to, this will have the address actually of the next node. So here 200, this is how they are linked, and the last link of this third node, this is the last node, its link is null. Now how to create a stack, how to implement the stack using the linked list. You know that in case of the stack, what things are important, insertion and deletion happens at the same end, right? And we have to also take care of the time complexity. Since in stack using the array, we have seen the time complexity was big O and then 1. That means independent of the size of the array. That is, you can see push and pop was taken from the top. So you don't need to worry about the size. It is very fast enough. It is very efficient. So in case of the linked list, since we have to implement the stack, we have to follow the principles of the stack. That is, insertion and deletion should happen at the same end. So you can see that in case of the linked list, this is the beginning actually, and this is the end. So suppose you have to insert and delete, therefore you can do either insertion and deletion at the beginning, or you can do insertion and deletion at the end. Now which way you will prefer? Let us see. So suppose I am inserting and deleting at the very beginning. Consider here we are having top. We'll use this name actually because we are creating a stack. Suppose I create a new node here. So in that case, the new node which is this new node, I should link to these nodes which are there in the linked list. So therefore new node link should be top. So what will be the code? The new node, we will see in detail with the coding, how to create a node dynamically and what all instructions are required. This is just in short. So new node link equal to top. New node link equal to top, right? So this is now linked to this. Now the top was here actually. Now since I have added new node, now my top should come here. So therefore what will be that case? So therefore then the top is equal to new node. So now the top will come here. It will be here. So this is the insertion. And what about the deletion? In case of the deletion, this is my node and I have to delete. So in that case, what will happen? This node, I have to remove this link of this node. So only these two nodes will be remaining. I will first of all make a copy actually of this node. Temp is equal to top. So I'm creating a copy of this node, and then actually this top is equal to top link. I have stored this copy in the temp actually, and now my top is here, and then I will free temp. So now therefore in that case I will have this. So all the things you can see, insertion and deletion I'm doing at the beginning itself, that is at the same end. Why same end? First of all, because we have to satisfy the principles of the stack, right? So therefore we are doing at the beginning. Now what is, you can see here what will be the time complexity. The time complexity here will be also big O and this one, that is independent of the size of the linked list. It should be O1, that is the best time complexity, which we have seen in the array also. So suppose I am inserting and deleting at the end. In that case, what will happen? So suppose I am creating a new node, right? I'm creating a new node. I'm allocating dynamically the memory for it. And then I have to insert here at the end. So I have to traverse from starting to the end, and then I have to create a node, and then I have to make a link. And also deletion, for deletion I have to again traverse from beginning to end, and then I have to reach to that node and I have to delete that node. So you can see here that how much will be the time complexity. It will be O of n. So it is not at all efficient and it will take lots of time. Depends upon the size of the list. What about if you are having the linked list. Actually, many nodes are there in that. You have to keep on traversing to reach to the end to just insert and delete actually. So this way we will not prefer. So we will insert and delete at the beginning itself in order to achieve a good time complexity. So this is the thing actually wherein we will be seeing in detail. We'll write a single instructions, whole program itself in C language. But this is also a quick question to you. Just few lines of code for you. So the code is that first of all you have to simply create a linked list, singly linked list. It is very simple code. Create singly linked list, that is LL, and then when you create a singly linked list, you have to create a nodes. You might be aware of that. And then you have to simply insert node beginning, insert node at end, delete node beginning and delete end. So I want you to write this few lines of instructions for this. And this is just actually for your practice purpose. This manner you will understand you are not alone. You all are there together with huge students. You can also create a singly linked list. You can perform one operation, that will be also fine. You can perform any of them. You can perform all of them. So I want you to just write the instructions and drop it, copy paste in the comment box actually. We will see, and if any doubt actually, that also you can give in the comment box. I will reply to that comment. So I want you to take this session as a very interactive. This is a simple question to you. I hope so. You reply in the comment box actually what instructions will be required. So now moving back actually, now we have seen in short about the stack using the array stack, using the linked list. We have also seen in stack using the array what disadvantages are there actually, and what all things we have to keep in mind in stack using an array and linked list.